caveat that it sometimes does impact on the on the bandwidth issues actually, but I don't mind at all. No, record away.
Okay, wonderful. Thank you.
No worries. Yeah, so as I say, I'm a philosopher at the University of Glasgow. I research and teach, write in philosophy. But I have this other job title, which is now on your screen, which is I am the Lord, this is what LCAS stands for, by the way. I am the Lord Kelvin Adam Smith Fellow for Virtual and Augmented Reality. Now, that's a ridiculous job title, but it basically means I'm like what other universities call a Chancellor's Fellow. That is, I have 5 years without teaching commitments, well, without heavy teaching commitments, to progress matters concerning VR and AR across the university, wherever I find them for colleagues and new projects and such like. And one of the main projects that I have pursued under my LCAS is Project Mobius, and from Project Mobius comes a product called Edify. And that's what we'll talk to you about today, and the possibility for you guys to either use it or get involved as contributors to it. Project Mobius is in combination with Sublime, and that is where Fergus comes in. So I'll let Fergus introduce himself.
Thanks, Neil. Hi, everyone. Yeah, Fergus Bruce. So I'm a director at Sublime. Sublime are the commercial partner for what was originally Mobius, is now Edify. And I am Neil's counterpart at Sublime, so counterpart project lead. And more generally, I'm a decommissioned philosopher, if there is such a thing. Academically, Neil and I did undergrad together, so we've known each other a long time. And I work on the kind of the commercial side of the business, but also project development, project initiation, and education sector lead. So that's my bag.
Super. Okay, so what we want to do is set a little bit of a scene for you about why it is that we set off to do Project Mobius. Project Mobius is a project to do with bringing virtual reality to teaching in higher education, but in a practical way. So here's a little kind of teaser video that gives you a sense of some of the things we think you can do. Go anywhere is a kind of key message, and when you get there you can do anything. I'll say a bit more about this in a moment, but what we're looking at here are actually some footage from a couple of our apps inside the bloodstream, and here conducting some diagnostic processes on a sample of the Zika virus. We want to be able to bring VR teaching, but we understand the practical limitations of VR headsets, and we can't get everyone in one. So Edify is a way of getting some of the benefits of VR teaching without everyone needing a headset. That's the headline there. So as I said, you can go anywhere in VR. So you can go, you can stand on Mars, you can go to the bottom of the Mariana Trench, you can go to the top of Mount Everest. There's any number of places you can go. You can go to impossible scales. You can go to the size of an atom. You can look down at a galaxy in your hand. There is sort of no limit on where you can go. And when you get there, you can do anything at all, right? So you can kill your patient several times over and try again. You can break the laws of physics. You can create stuff from nothing. You can measure things you can't really measure in the real world. So you can go anywhere and do anything. That's an almighty broad set of claims. And therefore, using VR, you could in theory be learning anything at all. You could learn everything in VR. Now, these are sort of like the grand visioning promises of what VR might be able to offer us at some future point down the line. What we wanted to ask as our project was, how do we take the first steps there, and how far along this path can we get? How can we kind of start the ball rolling in that direction given these grand promises? And that's where we initiated Project Mobius. So Project Mobius started at the University of Glasgow as a teaching competition. I asked colleagues in the university to supply ideas of what they would use virtual reality for if wishes were to come real. The important bit there is for them to set aside any worries they have about the cost, the practicalities, how the headsets work, how much space you need, how much does this cost? Like, just ignore all that for the moment, I said. Just tell me what you would use it for teaching if your wishes were to come real. What we got were about 38, I think, responses, some of which were impractical. They simply demanded hardware that wasn't possible yet in the world. However, the majority were very practical, very you know, plausible to create and really good ideas, and given the sort of teaching intervention that they would make. We had a short list of about 22, and then we brought that back down to 10 leading ideas which we considered to have won that competition. Now, the way the competition worked, and this is relevant for the funding competition we'll talk about later, is that we asked the colleagues in the uni for just 200 words initially to say what they would use VR for. And then the ones that were even remotely plausible, we did a second round of work with, where I briefed them on how you write a brief, how you write a VR app brief, and I got them to think through the various things that would make that more or less expensive, and then they submitted a final version. So that's how we worked through it with them. We got these 10 exemplars from this competition, and we used those to partner up with Sublime to then apply for government funding to try and bring virtual reality teaching practically to the fore. 10 apps was important because what we wanted to do was to create a critical mass of the software that justified the hardware that people would need. So we applied to Innovate UK and we were successful with that. The project is worth around £977,000 across the course of 3 years and started in October 2018. That money pays for the university to, pays for Sublime to build the apps and to take them to market. But it also pays for the university to build the infrastructure required to teach at scale. Now, if you've ever had a VR demo, you've probably had it one-on-one with the person who was leading that demo. But teaching can't happen one-on-one. It's far too expensive. So what we need for teaching is to be able to teach in larger numbers. So the infrastructure we had to build for VR had to be for those larger numbers, maybe classes of around 15 for kind of seminar or tutorial-sized classes. Students could go through 15 at a time. Each could occupy high quality, 6 degrees of freedom virtual reality headsets, and they could have a whole class and be in and out within an hour. So there's a lot of operational difficulty in making that happen, but that was my role, and the chap you see in the photograph on the slide. It was our job to make that happen in Glasgow. We were successful. We got these labs up and running. We got it so that teachers could just walk in, use it, walk back out again, and it was ready for the next class. Things were going very well indeed. However, coronavirus struck and it kicked us off campus, and we had to stop doing the testing of the apps and the infrastructure that we were doing then. Now, all along the way, we've understood that virtual reality headsets and this large-scale infrastructure would probably be off-putting for a whole bunch of different institutions who we did want to be using our apps, right? We wanted to have created this teaching platform and let other people use it, but there was a barrier in the way, which was the VR hardware and the infrastructure around it, the big space required. We understood that all the way along, and we had always understood that we might get to the point where we had the apps ready and they were mature, but that VR wasn't sufficiently ubiquitous for it to be easy to find a market for them. Now, COVID forced us to really press down on one of those issues and figure out how to get that benefit across, get the benefits of VR teaching across without the need to have that infrastructure. Oh, I've got some, there we go. Yeah, so that's what we did, right? We had to figure out a way in which we could get the benefit of VR teaching across without requiring that every teacher and every student would be wearing a VR headset at the time. And that is what makes for the platform Edify, and we call this solution VR by proxy. So that's what I'm about to demo for you just now. VR by proxy works, instead of having everybody wearing the VR headset and everyone in a virtual world, we have only one person in the virtual world, presumably the demonstrator or teacher. That person has all those powers of VR. They can go anywhere, they can do anything. But the people who aren't wearing VR headsets can follow along that journey, can play along. If you maybe know Twitch or sort of play along things on YouTube, where people watch other people play a game and feel involved in it and engaged with it. Well, that's what happens here, except there's more interaction. The students can ask questions of the teacher and the teacher can respond and act accordingly. But mainly the benefit comes from the fact that the teacher can control the VR environment and the students can partake via Zoom, via Teams or any other video conferencing platform. It changes the dynamics entirely of how many people we can reach and what the physical infrastructure any given university requires is. Okay, I'm just going to go and launch my demo. I'll come off of the camera and the microphone at the moment, leave you with Fergus for just a moment. I'll be back in a second.
Okay, so thanks, Neil. Yeah, so what you guys might want to do is pin Neil's camera so you get him full screen. So there should be 3 dots. If you hover over his camera, you should be able to pin him. That'll give you a nice full screen view of what we're about to see. But as he said, the key thing to get to understand, I suppose, here is that we're going to join him in VR. So we're going to we're going to share his immersive experience. In this case, it's a physics lab. So I don't know if there's any physicists here. Please identify yourself, because we don't. The physicists will get the answers right, but he's going to choose somebody, probably you, Nicola, to ask a question during this to get a learning outcome. So this is a physics class that was designed by physicists, or it was proposed by physicists at Glasgow University, which Sublime built. And it had to be, there was certain criteria which apply to the funding call that we have at the moment, which is that it had to be central to the teaching of physics. So anywhere in the world where you're taught physics, in first year you have to learn Newtonian mechanics, projectile motion. That means it's not parochial to Glasgow, so there's not a specific way that Glasgow teaches it. It's taught pretty much the same way everywhere around the world. And it had to use virtual reality or immersion, visual immersion, to deliver something pedagogical that you couldn't do in the real lab. So Neil's going to show you a little bit about what that actually means in practice. So it needed to be extensible to other institutions, to intersecting disciplines. So once you've got physics in a virtual space, then you can teach lots of subjects. So that was those were the kernels of the idea. Those were the core of the idea that we asked for. Now I'm just going to take a quick look and see there's some chat. All right, okay, not a physicist, but a chemist. Well, Joyce, you might, well, that's probably fine. It depends how much you know about Newtonian mechanics. Yeah, so we'll see when Neil comes back. There he is. So, Neil, do you want to just test your mic before I go?
Absolutely, yep. Is that okay?
Okay.
Fergus has to get me to test my mic because I have several different VR headsets plugged into the computer, and I have, on occasion, gone for the microphone on the wrong one. Okay, yes, Joyce, I'm afraid you have put yourself front and centre here. You're going to be my dummy student. So when the moment comes, I'm going to ask you to come off of the mute and talk. So I'll be a minute or two down the line, not just this moment. But yes, this is a dummy lesson, and I'm a dummy teacher, and none of this is pejorative, because I'm a philosopher, let me just remind you. But I'm going to run through a lesson that we can give in quick form in VR and show you some of the benefits that come from us being in VR. Okay, so hopefully you've got my full screen, as Fergus said, and again, we're hoping that the bandwidth doesn't get in the way of you seeing a fairly good quality and sharp representation here. I'll talk a little bit along the way about how we might mitigate things if there is a slightly worse connection. Okay, so hopefully you can see that I am in a physics lab. It's pretty mundane. There's mess everywhere. What I'm seeing is, really quite realistic, right? Very, very high quality environment. What we've got is a setup that is fairly ordinary or everyday. We have a bench here, a couple of ramps either side held in place by clamps, and we have a ball ready to drop onto the ramps to do our experiments with. Of course, in the real world, this would have taken a while to set up, and in fact, it'd take us a while to make each of the adjustments we wanted to the ramp height or the ball position. I can do all that instantly in here, and that's one benefit of VR, a relatively mild one. And of course, this is an operational benefit, right? This makes it easier to run the class if we can do it quicker and with less hassle. This was one of the major motivators, actually, for the teachers who suggested this mode. They said that the lessons that they taught in physics for 1,000 student cohort at a time took around 3 hours to run the labs, and that was in relatively small numbers and took members of staff and large amounts of space to run. So even the operational benefit, which is fairly banal, is still very valuable. However, things get really interesting pedagogically if we look over here for the physical settings. Here I have the powers of VR to vary the laws of physics. I can vary gravity, for example, or I can vary the elasticity or the friction applied to the surfaces in the scene. And friction's the one we're going to look at in a moment. So I'm going to run the first experiment here. And Joyce, I'm going to ask you just to watch this one and consider how the ball moves, because we're going to do the same experiment again in a moment without friction. So let's have a look. Okay, hopefully that's clear enough that the ball drops, it rolls, it reaches the end of the ramp over here, rolls back upon itself a few times before coming to a halt. Now, when it comes to a halt, we get this ghosted image of where the ball went. We see a snapshot of it every 25 milliseconds. Here, they're all bunched up because it was going relatively slowly, so it didn't travel far in 25 milliseconds. But then it stretches out and it travels further per 25 milliseconds as it goes faster. Then it slows again as it comes down here. By the time we get down to this bit here, it's quite noisy. There's an awful lot where the ball rolled back upon itself. And I'll show you a little bit about the tools we have to control that noise a little later. Okay, over to my right then, I get the experimental results, a readout of exactly what happened. Again, we can get this information if we observe things correctly in the real world, but this is all a lot quicker. So to reset and do my next experiment, involves far less effort than normal. I simply click a button and we're back to where we were. Okay, so now over to my left, I'm going to remove friction from the surfaces entirely. There will be no friction on the surfaces now, and I am about to run a second experiment. So Joyce, if you can come off the mute, I'm just going to show people one last tool that I've got here. I have control over what is being broadcast here. At the moment, you're seeing this camera, the one through my eyes, as it were. But as I move about or jiggle slightly as I talk, that'll move slightly and jiggle at your end, which is sometimes okay, but over a long period of time or for certain tasks is not ideal. Instead, I can create a new camera. I'll pull that camera to the position that I want it to be in for the purposes of this lesson, which is around about here. And then I will change my broadcast to that. Now, I said before, that might mitigate some of the issues with bandwidth because less changes in the scene at a time. I can still come into the scene, I can wave, I can gesticulate and all the rest of it, but now the camera is detached from my head, so there's less movement, less things changing, and that should help a little with bandwidth issues. Okay, Joyce, your time to shine. What I did the first time was I ran the experiment where the ball dropped, it rolled, it reached the end, and then rolled back upon itself. That was when the scene was set up the way the physical world is, the default physical settings. Yep. Now I have removed friction entirely from the surfaces. Can you predict for me two differences in how the ball might travel, please?
The one is the ball shouldn't actually ever come to a stop. And, well, actually, it might roll over the side on the right-hand side, one of the two. I'm not quite sure. It might go right over because it has enough momentum to carry on.
Yep.
Or it will oscillate between the two surfaces up to the same height.
Excellent. Right. So you're exactly right. And in this environment, we stop it after once it strikes the ground, just because that's how the app works. But you would be right, right? Without anything drawing energy out of the ball, right? And frictions does that, the ball wouldn't have a cause to stop. So exactly like you say, it'll come down here and it'll have the momentum sufficient to overcome this second ramp, precisely because the friction isn't drawing energy out of it, and it starts up high enough to overcome that ramp. So that certainly is an important difference. The one thing that is related to this, but most people don't get and allows me to have this dummy teaching moment, is to say one really interesting difference that you might not anticipate is that the ball will not roll. So the ball won't roll at all. When the ball drops and strikes the surface, in the presence of friction, friction now acts on the ball and stops it effectively. It doesn't completely stop it, but acts against it. That initiates the ball to roll down the hill. The very fact that it kind of sticks at the point that strikes the surface means that the top end takes the momentum and tips over. It creates a moment of torque, right? And that's what makes the ball roll. In the absence of friction, we won't have that moment of torque, and we won't have the ball rolling. So let's have a look. Grand. So what we get here is the trajectory of the ball. This is rather different to the first one, but that might not be apparent until we set them side by side. So let's do that. We can see both runs that we did here side by side, one with and one without friction, green being the first one, red the second. What I'm able to do, remember I said there was noise in this component down here, is I'm able to pull that out, right? And I can choose how much of the data I want to see of the two runs. I'll just do it till the red one roughly reaches the ground there. The other thing I'm able to do is I'm able to move my timer my slider along here and see the ball in two relative positions after the same period of time. So what I'll do now is I'll position that further up here. I will teleport to this point in the scene. I'll give you a wave. And then I will return things to the broadcast from my head for a moment as we take a look from here. Now, because the friction that we varied only acted on the surfaces, what we see is as the ball travelled down here before it struck the surface, its trajectory was identical on both different paths. Right? Because the difference between the two was only the friction of the surfaces and no surface was acting on it then, there's no difference to the trajectory of the ball. But if I teleport back over here and use my timer again to bring the ball down here, I can crouch down and show that's the difference that friction made. So I can show you that on the red, it's travelled that much further in the same period of time compared to the green. It's travelling faster. And exactly like you said, Joyce, it's because there is no nothing slowing it down, right? There's nothing going to stop it. And then we can just see the timer any point we like, and we see as the red ball keeps going, the friction starts acting upon the ball and slowing it down along with gravity as it goes up that slope, and the red wins away. Okay, that's effectively the dummy lesson done. The only thing I want to show you then is that I can hit export results, and here we get an export of the data from that experiment. We could have done 4 or 5, well, we could have done dozens of experiments and selected as many of them as we want to output, but we could have selected either 4 or 5 to view simultaneously with this kind of different coloured representation. So that's the tool that we have. That was one lesson. Some things that are important to point out. This is just the physics environment. We have 10 environments, 10 exemplars, and all of those exemplars sit on a platform where you can build your own app, build your own lesson within the app. So no matter what topic you're teaching, we've got a lesson creator that allows you to create your lesson in it. For some specific functionality, like how these balls operate and you know, exporting the results in this kind of time slider, that additional functionality is built into subject-specific or topic-specific exemplars that we've built. As I say, we've built 10 already. We'll talk a little bit about what other ones we've got, but we're looking for ideas for the next 10. So that's kind of part of what we want to talk about today. Notice as well that in this context, I only did one brief experiment, sorry, 2 experiments, but around one topic, which was the removal of friction. Those sliders go both directions to lots of different settings, and we had gravity, elasticity, the ball mass, the ball size, the ball position. We had all these things to vary. So there are dozens of lessons that can be done in this environment. In that sense, this exemplar isn't a lesson, it's a tool. It's a tool to create lessons around this topic that the teacher might want. So they're quite important things. Now, I'm just going to come back to the webcam in a moment. Before I do, does anybody want to see something in VR while I've got the headset on? Anything else in this environment you want me to do or show you? If not, I can just come back to the webcam and we can talk. No? That's fine. I'll be back in a moment.
Okay, thanks, Neil. I'm just going to start my video up again. You guys might want to unpin Neil unless you want to see his face full screen, which is a very nice sight, but entirely up to you. So again, just a few things to kind of to anchor there is that lesson, effectively that lab has to be run for 1,000 physics students at Glasgow every year. And it causes a lot of consternation. So because the students will claim that they're not getting the same test conditions, that the equipment is broken, and it takes an entire lab out of the physics department's life for a semester. So, and you can't vary gravity and you can't vary friction. So it's a tool that allows infinite iterations of a specific experiment in this case, but it could be 20 or 30 others. So as Neil said, it's a tool for teaching physics, which is common across all the 10 exemplar classes we already have.
Super. Okay, so at this point, we like to pause and let you guys get any questions off your chest you might have about what you've just seen, and certainly tell us what you think about what you've seen. Of course, bandwidth issues might have got in the way there. You can tell us about that, or how you found the experience. So that would be helpful for us, but also lets us digest what you've just seen before we go on with more information deluge.
Now come in here.
Certainly.
Joyce. So what I understand from this is a lesson creator, and then the demonstrator will wear a headset once the lesson has been created, and you will have to Zoom or any of those platforms with a class. Is that correct?
Yeah, except for the have to. So you don't have to use Zoom or Teams or any other platform. You could, in theory, stand at the front of a lecture theatre and have it play through the projector.
Yes.
But given the situation that we're in, and given the greater scope and reach that it would give you to do it via Zoom or Teams, that's certainly what the kind of one of the core benefits of it is.
Yes. So further from that question is, therefore, it has to be synchronous. So it's not building a demonstration that the students can watch in their own time or interact with in their own time.
Actually, they can. So what we did here was show you that it can be synchronous and show you that you can interact. I think it's best when you get the synchronicity and the interaction. I think that's like the ideal way in which, if it's practical, we will teach that way. But you can record the lesson that you do as a video, and you can upload it on your LMS. So you can upload it to Moodle or whatever system you use to distribute information like that to your students. You can put it on YouTube if you like. But we do think additional benefits come from being able to do the synchronous version. Moreover, what I didn't show you was that I had the option to launch this with or without VR headset. Right. So the environment I was in, the way I was controlling myself in that environment, the broadcast, the kind of tools I was using, all of that is built around VR and primarily for VR. But we're translating it all into being able to be used on keyboard and mouse as well. So you would need less of a specification of a PC, and you could do it at home. And as of next year, we'll even be able to do it on tablet. Now, we think you lose something every time you kind of move away from having the VR headset, right? That's why we built the things. That was the purpose of it. And yet we can see the benefit to students of being able to be at home doing these experiments for themselves in their own time. Not just watching you do them, but do them themselves. We think that's really powerful, and our software allows for that as of now.
Okay, cool. So there is you are looking at development for the students to be able to do it themselves.
Yeah,
fantastic.
Absolutely.
Thank you.
So that can be, that sort of answers, I think, the second part of Neil's question, which is, yes, it can be completely asynchronous if you so choose to do it. You can just record what you saw there on the screen in fully high quality, right? So that it can be downloaded rather than streamed, and that's that's built into what the software is capable of. The other part of your question there, Neil, was about the data. The amount of data it would use for a session. I take it you mean bandwidth data here. I actually don't know. The VR element here is no different from the stream. What I did there was I put on VR and I told the computer to treat the VR signal as a webcam feed. So it is equivalent to having just a webcam on. Now, and I know that can be still in some contexts problematic, and that's where you might want to think about the asynchronous stuff. And maybe that's why you're asking about the asynchronous stuff. Maybe that is a live concern for you.
Here's a question we had from elsewhere in South Africa about data access for a lot of your students, and particularly if people are back at home and not on campus or working partially from home. The data is expensive, and being able to stream things and whatnot. So we answered that question pretty much the same way. Is that even if you teach a synchronous session, you can record it like we're recording this one, and then upload it to the LMS, and they can get it on their own time.
Okay. Anything more for just now? We've plenty of time for questions. We've just got a few more things to tell you, mainly about the competition, actually. But maybe we should run through first the kind of smorgasbord of exemplars that we have. So again, to set the scene a little bit, we think about the Edify platform as being a little bit like PowerPoint, right? You bring your teaching materials. These aren't lessons that we give you that, exchange your teaching, right? These are tools you can use to do your teaching, just like PowerPoint's a tool for doing your teaching. You bring along the assets that you want in our lesson creator. That can be images or animations. It can be PDFs. It can be sounds. Or, crucially, because we're using VR, it can be 3D objects, 3D terrains, 3D models that you can bring in and you can teach with. You can rotate them, expand them, annotate them, run a section through them, all while you've got the tools to control the broadcast like I did with different cameras. You could have up to 4 or 5 different cameras simultaneously. That's the toolkit that Edify allows you to have. What we can show you now is what we've done with that toolkit when guided by teachers to do some to build some extra tools in that in the platform. So the first one that we'll show you here goes inside the arteries. right? So it goes inside inside the arteries to see the blood flow and to be able to control different pharmaceutical interventions in respect of hypertension or the like. And then you get to see what happens at this scale and from the inside under each of these different variations. Again, this is guided by the anatomists who told us that they had real problems getting some of this information across to students, and it's really crucial, of course, in the medical
physics you've just seen. So
yeah.
let's skip along to the protein viewer.
Protein viewer, exactly. So we have built a viewer that allows you to see proteins from the protein database, right? So this is an open database of tens of thousands of proteins. What the tool allows you to do is compare them side by side, perhaps lock them so that when you rotate or scale one, it rotates or scales the other. And then you can measure different points across the amino chains, which is really, really important for understanding what the nature of the mutation between two nearly identical proteins is. That really tells you about how it causes the diseases that it does. Here we've got the path through the infection of salmonella that takes us to, as Fergus was kind enough to remind me yesterday, to the submucosa, having come through from the gut, and now into the lymph node, next into the lymph node. This is where we can start to act out some of the interventions that the body makes in respect of having a salmonella infection, and you can get this wrong, and you can nigh on kill your patient, but then you can try again and get it right. We saw this in the teaser trailer. This is our diagnostic lab. In this lab, we've built in the logic for the process of analysing a Zika virus, so or a sample of Zika virus. So this is where you need to do each thing in the right order to the right extent, using the different pipettes you have, then take it to the centrifuge, then to the qPCR machine, and have that sample analysed. Then that analysis produces a result that the students are able to get hold of. As I say, this is all hard-baked to Zika virus at the moment, but it's very simple, and we're in the process of looking at doing it for HIV or for Ebola or indeed for the coronavirus. The process is largely the same. It's the steps and the volumes that vary, effectively. Okay, another one from the kind of anatomists and physiologists is inside the body here. What we get to see is the inside of the stomach as food turns up. Not an environment I would particularly want to see, but I didn't do medicine. And you can use this magnifier to see what's happening at the cellular level on the walls of the stomach as you're inside the stomach, controlling the different interventions, right? And then you can start to see what difference that makes to, for example, the pH level in the sea. The next one's the philosophy one. So this is from my subject area, although it wasn't my proposal. One from one of my colleagues who, in fact, works on ethics. This is the trolley problem, which is a classic dilemma case that teaches us a lot about how we reason and how we reason badly around ethical matters. And it's by controlling an out-of-control train in respect of the lives of people who are on the tracks. Students often are told what happens in these cases rather than shown or asked to conduct it themselves. And as a result, we end up getting some what we think are kind of unrealistic or unrepresentative things that they say. In other words, they tell us what they wish, what they like to think of themselves as doing, not maybe what they would have really done under the circumstances. Here's another one from the College of Arts. This one comes from information studies, history effectively, and concerns the Gutenberg press. Here you can set the page on the Gutenberg press. You need to set the text upside down and back to front to get it to press correctly. You then ink the text, you press the frisket down, and you press the page. So once you've pressed the page, you can get the output of that, and that comes with, here we go, lorem ipsum, followed by jumps over the lazy dog, and that's with all of your spelling mistakes and inking mistakes in it as a PDF. Here's a field trip. Very natural thing to want to do in VR is take a field trip somewhere that's otherwise difficult, expensive, or in some other way problematic to get to. This is a globally significant, we are told, and we believe it, a globally significant geological site on the island of Arran. And we have created a photogrammetry model of that allows the student to explore it and then to conduct some field work, that is to produce observations and recordings of the dip and strike and such like on the rocks. And here we have data landscapes. So this is a very general tool for viewing data in 3D. The people that proposed it wanted to look at social data, housing, age, and social demographic, and be able to set these things against each other on a 3-axis representation that makes data end up looking like a landscape, right? It looks like mountainous regions. What that means is we start to see patterns in that data because we're used to seeing three-dimensional things like terrains, we start to see patterns in it on that basis. And at the end here, we've got a very early draft of this lesson creator that I spoke of. The lesson creator defaults to being like a virtual lecture theatre. Maybe that's a good way to start thinking about it. Imagine you could do your lecture in VR. You can draw on a virtual whiteboard or chalkboard. You can represent your slides on a screen. You can boot up bits of the web or bring in these 3D models and use them. You can control what the students see, and you can do whatever you like in this environment for your teaching. Now, it defaults to a lecture theatre, but could equally be a lab. It could be the Colosseum in Rome. It could be Mars. And what we've done on the platform is to build in a library of different options in respect of what those environments are for you just at the start, but you can go and produce your own or buy your own from model libraries. They usually cost less than $100, for example. Sometimes they're free, and you can create environments of historical significant sites or whatever you like in order to be able to have your class there, and you'll still have a virtual whiteboard, a virtual chalkboard, and all the rest of it with you when you're there. You'll already have all these tools available to you. So you can see, hopefully, how that acts a bit like an interactive immersive PowerPoint presentation, and you can curate your whole lesson in there and deliver it, as we've just been talking about, either synchronously or asynchronously, depending on your context, your preference. So that is the 10 exemplars that are on the app, are on the platform as the initial additional tools that we built in for those subject areas, directed by teachers for teachers, to give it that kind of validation of it being useful. Hopefully you notice that they are all fairly central to the curriculum, right? So if you're learning physics, you just have to learn Newtonian mechanics. If you are learning anatomy, you need to know about the inside of the stomach and the inside of the arteries. So they apply at the center of the subject area, and therefore apply to everyone who might be taught that. And that was one of the kind of desideratum of this, of the ideas when we were assessing them as part of the competition. So that was competition number 1, 2017, that got us the money, that got us the project, that let us build it. There is now a funding opportunity open that Sublime are running, with the additional funding that they've managed to raise against the fact that Edify can work in this by proxy across Zoom or Teams fashion. That competition is open till the 11th of September. And just like the one in Glasgow, we're asking initially just for 200 words by way of an idea. And anyone from any discipline, from any walk of life, can apply. And they can send in their idea. At which point, if they're selected for the second round, what we'll do is I will give a tutorial on how to build your brief to make it more attractive for Sublime, right? To make it cheaper, to make it more of a tool, less of a lesson in a box, you know, less of a canned lesson and more of a tool for many lessons. And I'll talk people through the different steps in which you can think through that. Then people will meet with the developers to refine the brief even further. And by the end, the thing that you will submit for assessment by Sublime is a fully complete brief for what a virtual reality app could be for the idea that you guys have come up with. That brief should be valuable to you in the future, whether you're successful on the bid or not, because you can get it built elsewhere, or you can specify it later if you want to pay for it to be put onto the platform. But you could also win this the app to be built. If you win, we build the software, we build the tool in collaboration with your teachers to guide what it should do to get the right ILOs. And then at the end of that process, that kind of tool becomes one of the many exemplars that will now sit on the Edify platform. And you receive the software that you've helped specify. You receive a version of that to use for your institution in perpetuity. You would never pay for it. And what you're winning there is effectively then the cost of development, which will be between £20,000 and £40,000 per application, per teaching intervention. So that's the competition. That's what's open just now. Of course, you may have already seen the app that would be ideal for you and your teaching right now, at which point Edify has got a beta that is open in September that you can sign up to and have a try of the software. And then it launches commercially at the end of September. To give you a sense of costs, which I know is a concern for anyone in higher education at the moment. The costs are very reasonable. If you were to have to build one of the big 15-person labs or something like that, I could see that might, as I said before, we were aware that could be a barrier. You would be talking tens of thousands of pounds to build that, so about probably 40, 50,000 pounds to build that infrastructure. But now you just need one VR station. So you need a PC that's about £1,500 and a headset that's about another £400. So around £2,000, or if you push the boat a little, £2,500 will get you a setup that can be used by various different teachers all throughout the day. In other words, one VR headset, one VR system would be able to go a long way. I'm aware that I'm talking in pounds here, but we've been speaking to people in Hong Kong, Singapore, Malaysia, Australia, all across the world, and I am not so good at doing live exchange rate calculations, I'm afraid. I'll leave you to do that. The software itself, then, once you have the physical infrastructure, once you have the hardware, and again, in most universities, somebody somewhere has a VR headset they're probably not using right this minute, so you can test on that. Once you've got the hardware, then the software costs £30 per month per teacher who wants to teach on it. So if you've only got 5 teachers that would use it, you need 5 teacher licenses. And the students, of course, don't pay for anything if they're receiving the lesson via Zoom or Teams or whatever your video conferencing platform, or your LMS if you're doing it asynchronously. The student doesn't have to pay anything. If the student wants the software on their own device and wants to play with it themselves, that comes at the cost of £10 per month. But we anticipate that institutions who want to use this en masse would probably want to buy 50 or 100 teacher licenses, and therefore there's volume discount there, but also may want to buy a set of student licenses that can float between the different students. I guess a little bit like short loan books in a library or similar. So you don't need one book per student who is on the subject. You don't need one license for Edify per student, but you maybe need enough to cover how many students would want to use it at the same time. So maybe that's 100 or 200 in the institution. Hopefully those costs aren't too off-putting. I think given the kind of range of software, every license gets you every exemplar and gets you the lesson creator as well. So we think this stands really good value for money in respect to the software that's available, and we're hoping that the hardware being just one kit required across perhaps even an institution, depending on how thoroughly used it is, we really hope that that will be that won't be off-putting either. Okay, I think I've gotten across everything that I wanted to. I did say it would be an information deluge, and slightly apologetic for being there being quite so much of it. We will follow up afterwards with some of this in reference material. So we'll give you a PDF that explains the competition, for example. We'll give you a link to the video that will show you those exemplars that we ran through briefly here, and some more information about how you can sort of get involved. But that's all I want to get across in your direction. And now, again, it's quite typical that people have some questions about that, and we're happy to take them.
Thank you, Neil. That was really fascinating. So, folks, if you've got any questions you'd like to ask, please feel free to take the mic or to type in the text chat.
Nothing
Can I
to
ask
ask,
another
just
one,
to
please?
say fantastic. It's mind-blowing. It really opens up science fiction-y kind of what was in movies, and you can do it in a classroom now. So thank you very much. It really expands the mind. Even the things that we're currently teaching, even if you don't win the competition, just things that you can do. So thank you very much, and to Nicola and Neil for the opportunity of engaging with us.
Thanks, Letitia. I'm going to quote you on all of that. Just you can.
Of course you can. Of course you can. Yeah.
Excellent. No, that's really nice to hear. And it is, I mean, I've said before, Fergus and I are doing lots of these demos because we know that's how you've got to get this idea across. You can't just, hope people read about it and understand it or something. And that could be jading if we did too many of them, but it's really nice to hear positive feedback from it, and it's really nice to hear people get as enthused about it as we have been now for several years, but we're able to get it out. And I think that's a really good way of thinking about it. This kind of go anywhere and do anything kind of tagline for what we think is possible could as well be said any special effects you've ever seen in a movie can be recreated here, right? So
Yeah.
all the rules are off, all the constraints are off. Now your imagination, okay, and a little bit of budget to build the thing, but we're trying to sort that too. It's now your imagination that's the limit. How would you teach this? Not how do you currently and what would this do for that? How could you teach this? And
I know. But, you know, us older academics need a little more prompting than the younger guys. So we appreciate the opportunity for you to share your creativity with us, because it forces us to think beyond, you know, our normal kind of 10, 20 year, you know, this is what we've been doing. So really appreciate it.
Yeah, I think it's worth saying from Neil's point of view as well, when he ran the original competition at Glasgow, he didn't know if he would get, if that creativity was out there, or whether, you know, whether there would be any ideas, but he was 30 or 40 really great. They were all good, you know, when you take the kind of brakes off your imagination with this, is that you really can go anywhere and do anything. And what was interesting from our point of view was learning what is difficult to teach because it's small, or because it's 3D but far away, or because you can't see it or you can't get to it. And they would often, you know, the educators would tell us that we don't often learn that the students haven't quite got it until we test them on it, which might be like weeks or months after they had the lesson. It's like, that's not what I thought a protein looked like, you know, that we did get these strange things, because it's an abstraction, right? So being able to give them a kind of ringside seat. And this demonstrator, whether it's synchronous or asynchronous, is like an old style practical. You know, it's like watch a lecture or do something in front of you. It's got this kind of mirror learning pedagogical value. So we're super excited about it, because we don't know where the edges of that are yet. You know, so that's what we're asking people. It's just
well, your excitement is infectious. Thank you very much for infecting us in a positive way.
Everyone from Scotland is like that. So
oh, I wish it were so. Yes, and as I said before, some of the things we anticipate are a bit of friction, as you said, and the older academics might be a good predictor for it. But the friction's really in people being a bit intimidated by the hardware, or a bit intimidated by the newfangledness of what they're seeing, right? And that's been a real driver on the user interface and user experience design on the kind of software side, right? So we know that people who put this on are probably not, for the first time to do teaching or whatever, are probably not going to be, you know, VR aficionados. That's not the point. We want to get it across to the point where somebody with, and when we did it in the you know, in the physical labs pre-COVID, this was borne out. We only needed about an hour for the teacher to completely familiarise themselves with the app that they were using, which is, you know, a remarkably short, you know, learning curve. Myself and Jonathan had done an awful lot of work to make sure that they didn't have to understand what was going on in respect to, you know, the PCs that were running, and they just had to put a headset on. The things would be ready to go, and it took them less than an hour, actually, to about 20 minutes, but we give them the full hour to practice, and that was more than sufficient. The rest of the time we spent telling them, you know, how to wipe down the headsets afterwards with anti-bac and that kind of thing. It was more practical. So we have made it as accessible as possible, and I'm seeing Sandil there saying it's exciting to see the possibility. It is, and what we don't want to do is leave you with the impression that this is something that's going to happen a few years hence. This is here. We've got it. We are tweaking some bits about where the text goes in the apps. So maybe you saw in the physics one that the text, some of it in the far distance probably wasn't readable to you. It was perfect for me. But because the shift in emphasis has come from being the student, the person learning is wearing the VR headset, to being the person learning is not wearing the VR headset, we now need to shift where the text occurs and how big it is. Very minor changes, but that's the thing that we're just kind of changing over from where the apps were pre-COVID to how they are now in this kind of Edify mode of by proxy. So basically it's here. We're doing the beta in September to let people get a try, and then we're commercially launching so people could be using it this semester.
I think just to anticipate another question that comes along, Neil, just we were talking about how
Sure.
easy it is. This will eventually seamlessly integrate with LMSs like Moodle and Canvas, but the outputs from it are already compatible with LMSs. So it's mostly spreadsheets, videos, the kind of files that Moodle and Canvas or whatever you've got internally already support. So the teacher's not going to be asked to learn to use a new format or to be given anything else that they wouldn't already put up to their LMS after a normal lecture. So, but the idea is that we'll eventually there'll be a completely smooth connection between them all, but at the moment it's exactly the same process you would go through with sharing post-lecture material through an LMS.
Thanks.
Yeah, thank you. Thanks, Fergus. And Neil, also I see Joyce, you wanted to take the mic and ask a question.
Thank you, Nicola. I just want to make quite sure if I understand this correctly. You spoke about a lesson creator. So if, say, someone wins, gets a chance in the competition, is it that your system sets things up and from there, it is easy for a lecturer to create different scenarios, except, I mean, I saw the physics one with the ball falling and we could change the gravity and we could change the friction and stuff like that. Is that the only change, or could the lecturer from there use projectile motion or pushing and pulling rather than gravity?
Right. Yeah, I understand. So the thing we call the lesson creator is almost like the one app that rules them all, right? So in the lesson creator, you turn up and you have a choice of your environment. And we showed you one, a very early draft, as I say, that had a lecture theatre as that environment. And then you can bring in assets into that environment and you can select tool sets that you want in that environment. So one of the tool sets there was a whiteboard, for example. Another was a projection screen. That lesson creator will eventually have all of the different tools that we have across all of our exemplars, right? So we'll be able to have the magnifying glass tool that you saw in the stomach example, or you'll have control over the physical parameters and a ball as you did in the physics one. But what we're asking for by way of the suggestions is for what other tool sets, if you like, do we need to build, right? What do you need to be able to do? The protein viewer needed to be able to measure with nanometer accuracy across different links and the amino chains across a protein. That's what they needed. So we needed to build that tool, which you wouldn't have been able to have if you just loaded in the model of the protein, right? It also needed to be able to understand how to represent that protein. So we needed to build a specific tool set around importing proteins so they look a certain way. So you can tell us what things you would need to be able to do. Maybe in your subject area, there are vast databases of files or models that would be really useful if only you could ... Maybe cut them open, maybe expand them really big and change their color, or, you know, represent them a certain way. So that stuff is the stuff that we would need to build a tool specific to that kind of need and build it on as a kind of one of the many tools you can select when you're in the lesson creator. Then anybody coming along in your subject area could do, okay, I want to now be, let's say it was archaeology. Say, okay, now I want to be on this archaeological site that's in the library. I want to use these artifacts from that library I was talking about, and we want to be able to see them with the treatment that shows their texture. I don't know. Right. Yeah. So that sort of set of choices would be available to you only if you've built the tool that lets you see the texture. I'm picking a random example of the objects that come in. The question for us, and that's the question of the competition, is what tools do we need to add? Now, maybe we don't need to add any. That's kind of cool too, right? That means the thing's ready for you right now. And you can go into the lesson creator, you can bring in the 3D models, and just how they load in is fine for you. Maybe in archaeology this is the case, in fact, and you can move them around and talk to the students about them, and that's done all the job you need it to do. Then you don't need extra tools, and you don't need to submit on the competition. But if you want to do, for example, you want to be able to look through those microscopes that we've got adorning the environment in the diagnostic lab. If you want to look through the microscopes and see cool things underneath them, then you need to tell us what that should show you and how that should work and what samples we would need to build in a library. So that's the kind of way, that's the idea. You tell us the tools that we build in, and then you can build lessons around that, or you just build the lessons around the tools we've already given you.
So another way of thinking about it is, again, if we'll give you the criteria, we'll share, you know, there's like 3 main criteria for it that we'll judge the entries by. You can't just think about it in terms of a lesson, in terms of what would it be really cool to teach, what's hard to teach any other way with existing materials. So I don't know if you said you were chemistry, Joyce. There must be lots of difficult, you know, lots of 3D things that students struggle to get on board with. If you think about a typical challenging lesson that's far away, deep, tiny, 3D, difficult to access, you'll naturally start to think of tools just by that you'll need to do that. And that's part of the process of going through with us. Is like, I really need to be able to teach this. We are going to have a blank chemistry lab. We're in the middle of building it. But what lessons would it be ideal to teach using, if you could do anywhere go anywhere, do anything. And then we can help people reverse engineer. Well, you need that tool. If we gave you that tool, how useful would it be if you to teach 15 other lessons? You know, that's the kind of thing we're looking at, the kind of core to teach chemistry in VR. We need this tool set, and then we start from the kind of pedagogical or curricular requirement, the ILOs, you know, but what are you trying to teach, what's hard to teach, and then there'll always be a set of, this is what we asked the original app champions at Glasgow, is what do you need to teach? And then we went through the process of going, well, that needs that tool, and they'd say, well, we need to be able to do that. It's like, well, we need to build that. And then so that's the process.
Cool. And next steps, how do you suggest, you're going to send me some info with the criteria to share and how folks can submit their submissions, right?
Absolutely. Fergus will take on now, given that he's at the Sublime end that kind of follows up on these things. I'm here if you want to kind of ask academic questions. That's my role here, and particularly things around the operational side, which I've been heavily involved in sorting out in Glasgow. And Fergus can talk to you about the competition and the software and the beta and subscription, all that kind of stuff, and he can follow up separately with that.
Yeah. So
okay, wonderful.
Time is slightly short. We may extend the deadline, but don't assume we're going to. But it's, again, Neil says that the original, all we need at this point is up to 200 words of the kernel of the teaching idea. What is it you think you could do, or what is it you think you need? And then we will help for the people who get filtered through to each stage. We'll help build that up into a functional brief that we can actually build.
I just see Sandila's hand is up, so maybe there's a question.
Yes, thank you so much, colleagues. Very interesting and informative presentation. I apologize that I joined a bit late, but I was able to see what's going on. And just a simple question from our side, from pharmacy. I'm just bringing a theoretical problem. Is it possible to handle something that looks like a beaker, you throw in water, you put colors, and you make a formulation for students to actually start seeing how this is done? That's just the first one that I have. Mm-hmm. And on the second one, I've seen one university in the UK where they have showing virtually how they conduct their clinical rotation in hospital, but obviously using some proxy kind of a cartoonish material, if I may put it like that. Mm-hmm. So, does this space really provide such? Thank you.
Yes, so if you can specify really clearly all the different things that need to happen, right? So take substance A and substance B and put them into a beaker of a certain size, then this happens. And different substances and different ones, different things happen. It can look a certain way, it can bubble, you can see gases released, right? Whatever you think you want to see under those circumstances. Absolutely, yes, that's totally practically and technically doable. The question we would ask when we're assessing that as part of the competition is, how broadly applicable is that? How many students will benefit? How important is it that we've used VR to do this? What did VR get us? So in the physics case, gets you you can ignore gravity. You also get operational benefits, right? You do things quicker or faster remotely. Those are benefits, but you would need to articulate that really clearly, what the benefits of that were and that kind of thing. So just a heads up about what you would need to do in that situation. Another question we've had from pharmacists before, and we think it's a very good one, is can we build a virtual dispensary that allows people to practice the act of dispensing and getting it right and going to get the right things and mixing the right way and supplying it the right way. And that's entirely right. And there we've got a question of realism coming from pharmacists about how realistic we can make that dispensary environment. Very, very realistic is the point. doesn't need to be Toy Town or cartoonish. It can be very, very realistic indeed. For things like the protein viewer, cartoonish is better, right? It makes it look and pop better. But for things where we want people to get used to a real world environment, we want the realism in there, and the realism is possible. However, in the hospital rotation cases that you're talking about, it matters a lot whether or not there will be people in the scene. So virtual people acting a certain way, engaging in any dialogue, gesturing in any way, all of that is extremely hard to get right in any virtual environment, no matter how big your budget is. But even trying to do it reasonably simply might burst the budget of the kind of funding that we've got there. It would normally cost more than £40,000 to build an app that had that in it. We would also ask what the benefit of that is more broadly and whether it reached enough students and all the rest of it, but it might even just not work because it has this requirement. That is basically impossible to get real enough at the moment, and it's known as uncanny valley in the VR world. It's where the engagement you have with that person unsettles you because it's not quite realistic and it feels a bit creepy, right? And we definitely want to avoid that. So ideas that have people in them need to be very carefully thought through and need to be curated. And the hospital rotation stuff, seeing patients, engaging with colleagues, all that kind of thing, super ambitious, but probably has to be cartoonish to be affordable and therefore loses some of the value of it. That's normally how I think about those cases. But look, we're open to be persuaded through a dialogue, through the competition. I'm sorry to say I need to go. I have another meeting that I'm a bit late for. I would like to be able to take all the questions. In fact, please do get in touch and follow up with emails if you're interested in asking some more there. But I do need to run. But thank you very much for hosting us. Thanks very much for having us.
So Nicola, I'll send you the follow. I don't have everyone's details, so I'll send that to you, and feel free to circulate that to everybody or as many people.
Yes, so what I'll do is then I'll circulate the info you share along with the recording. And hopefully you get some interesting briefs. So thank you so much for both Neil and Fergus taking the time to chat to us. We really appreciate it. And guys,
Thanks,
if you're
folks.
looking for a sort of Africa-wide audience, I can put you in touch if you're keen to do another session.
Very much so. Yeah, we're trying to do big demos. Is obviously much more efficient for us. So if there's a wider audience, we'd definitely be interested.
I'll leave Fergus to pick that up. Better run. Thanks everybody.
Okay,
Really
cool.
appreciate it. Bye
Thank
now.
you, everyone. Yeah, I'll mail you, Fergus.
Perfect. Thanks. Yeah, I'll follow up with you, and then we'll get into a dialogue that way.
Okay, wonderful. Thank you, everyone.
Thanks, guys. Really appreciate it.
Thanks, guys. Thank you. Cheers.